It asks you to calculate error, but it doesn't give you anything other than like
Yep. We did that one before, I think, but we'll do it again. Everybody. So this is that. Is that the problem with like the 69,000 something?
yeah.
Okay. So we did this problem, I think. If it was this, the great thing about math is if you do a problem with nicer numbers, you do the same thing with the uglier numbers. Because the ideas of math don't care what the numbers are in the problem. If this is my confidence interval, what was my sample mean? Where is the sample mean in the confidence interval? How do I create a confidence interval? I take the mean and I add and subtract the same amount. Therefore, the sample mean should be right in the middle. So if I had uglier numbers, I would average them. But I could just see it 6, but if I average them, I see it 6.
So I get that part, but they asked for the error.
All right. How far away from 6 is either extreme? There. So the error must be 1, because that's what I added and subtracted to get 5 and 7.
So you should calculate what.
How far the middle is away from either side. In fact, that'd be a check. It should be the same distance from either side. Maybe. So we did that problem the other day. It's the one with the 69,000 or something. I can remember. Yeah. Yes.
I have a question about the
Okay, sure.
So, for the bottom one, it was like the 3% and then squared that equation. So on the first one, it didn't tell you it was 3% until you went to C.
No. So on the first part of that, I'm not going to tell you what it's within because you're going to calculate what the error is. Because I knew the sample size, I knew the n and the p hat and the q hat for the first part. You calculate what the error is. And then I said, how big of a sample do you need to get to make the error just 3%? So then the error is 0.03, not 3. Right. We always use the decimal, the real number, not the made-up percentage number. Okay, maybe.
But on the first one, on the first Z-score, the question you give us, like, if you use Z-score, it's a part of sample standard deviation, right? But
If I give you only the sample standard deviation, which is the only thing I gave you on that first problem, you have to use a t-square.
But like you give us the information.
I did.
The standard deviation.
Totally. Yeah, of course. I got to give you a standard deviation. So whenever somebody says I can use a z-score because you told us the standard deviation, that makes 0 sense to me because how many kinds of standard deviations are there? A couple. Sample, population.
Okay, if you like, you give us like the data and then with a number, and then first you give us the standard deviation, and then from the data you give us another sample and another standard deviation.
Did that happen on the, what are you talking about?
No, it's not happening in the test,
Oh.
it's just like the question is like I consider the standard deviation in the z-score because that's the whole thing.
I don't understand. So if I gave you a population standard deviation, then you're allowed to use a z-score if it's normal, right? Yes. On the first problem on the quiz, I did not tell you the population standard deviation. I told you what they found from the sample they took. It says so many parents were surveyed on Halloween. Their kids ate a mean of, okay, that's the sample mean, with a standard deviation, okay, that's the sample standard deviation because it came from the survey I took.
The question is 51 parents.
Yes.
51 parents. It's like
Sure.
the whole part of the survey. So
No, it's 51 of them. It's 51 parents. Are there only 51 parents?
Okay.
Man, they were busy. They made 360 million of us from 51 parents. They need a break. All right. You with me?
Yeah, I got
You
it.
can't say, well, it was all the ones you looked at. No, the ones I looked at make a sample. That is the definition of a sample. It's got to have some kind of a size to it. And I talk about all of them, it's still a sample. Where did I take that from? All parents.
Yeah, I thought that
Who
you
gave their
talking
kids
all
candy and
down
all
the
that?
population.
Huh?
I thought that you talking all of them. It would be population.
No, definitely not.
It would still be
Obviously not. Yeah, I took a sample. Guys, anything else from homework or that quiz? Well, it's still in your brain. Huh? You're like, I flushed it out the minute I gave it. All right, guys. So nothing from homework stuff then. All right. Just to remind you guys, in the homework, section 9.5 is where the full hypotheses tests live, right? And they ask you to use a certain worksheet in the back of the book. And what have I said about that? Don't use it. Use the one where the 5 steps we use. Theirs is based on using the calculator way too much. They get all their stuff in the calculator. And you're like, man, why can't we be like that? Because we want to learn shit. And even if you don't, I don't care. I'm going to make you learn shit. Try to. All right. So there's no questions from homework. Help me remember this. We finished I had 2 hypotheses test worksheets that we worked on last time. And we did finish those, right?
Yes.
I bring it with it's weird. No, it's just that. So we had the one that had the coyotes. That was the first one. The explanations. Somebody need that one? Yeah? All right. All right. So there was then we had the one with Ford Focus assembly time. Does that sound familiar? Then we had the sheet with the age that a mother was at the first birth of the first child. We did that one. Say again, sorry?
You did the Ford Focus one?
Credit card debt, okay. All right. And the coyotes. But we didn't do the mamas up there. Really? We didn't? All right. Shit. So, let's do this. Let's review some ideas about hypothesis tests. I apparently have to run back to my office and get the... it's weird. What's that? We don't have to do this. You don't want so much practice? I could do these problems with less practice, Jeff. What are you talking about? All right. I thought we had done that already. That's going to suck. Okay. So if you've missed the last few lectures involving hypothesis tests, holy shit, watch the lectures on YouTube. My dear God, right? You've missed a lot. The whole idea, though, is we have these 2 opinions about something, right? These 2 feelings about something. So somebody could feel like the gas price in San Diego is higher than it was last year or something. That's a claim. And we can figure out where it would go. So if that was what it was, we think the gas price now is higher than it was, let's say last year it was $3.69 or whatever at this time. So we feel like it's higher now, the average gas price. All right. So that must be fighting against some opposite possible belief. First off, where would that go?
Hi.
Hi, how you doing? Oh, there we go, right there. Because there's no equal sign. And what's the opposite of that statement? You less than or equal to. I like it. So, Why do we always do that? Because I want the statement that is here to be the one I can show evidence for. Any sample I take is not going to be almost impossible for the mean of it to be equal to the real mean. It's going to be really unlikely. So I can't use a sample to show evidence of equality. But I can use a sample to show evidence that it's not equal to in some way. So this guy is always the one that thinks it's somewhere in here. And this guy is the one that thinks, no, in this case, he thinks it's up there somewhere. So if I do find a sample that is here, if I find a sample that is there, which guy looks like he's wrong? No. Right? Because that's the one that thought it was in here somewhere. That's the whole idea of this is not, and on this other side it's not good enough to maybe be 370. Sure, that's more, but it's not much more, and it's just a sample, so it's not good enough evidence. The sample could be anything. If it really is 369, so here's the real thing. If the mean really is 369 right now, any sample I take should be close to that. So all this is doing is defining where does far enough away start. That's that third step, the rejection region step. I define how many steps away is far enough away to be evidence that it ain't this. So if somebody's like, I believe the average age of people here is 28, and you take a sample and you get an average age of 28.3, are you going to go, you're so wrong? It wasn't 28, it's 20, but no, it's not evidence that he's wrong. It's actually kind of evidence he's right. I guess maybe, no. So not only does it have to be different, it has to be different enough, because it's just a poor little sample. In order for it to show evidence, it's got to be really far away in whatever direction I'm interested in. Okay, maybe. All right, so I mean, this is step one, this is step A. Step B was really the Z or T thing. That's the little detail, right? What am I going to use to define this? So of course that's going to be a step, just like it was a step on what we just did. Yes.
On like any quiz or test, would you have it broken down for us in steps or like?
Yes. So on the quiz, it will definitely be broken out.
Like an A, B, C.
Yeah, and on the test, I give you at least one problem that has the steps, and I might have another problem that says use the same steps from whatever. Yeah. That would be so mean of me to have all these worksheets with all the steps and go, no, I'm not going to give you the steps. So you will, I will give you them, and you just have to answer them. Yeah. Let me see what I was about to say. Oh, step one is what the hell are we talking about? Step two is what can we use to talk about it? Zort. Step three is what's good enough evidence? How far away does a sample have to get? And then the next step makes sense. How the hell far away did our sample get? I know how far away I needed to get. How far away did we get? And then E is the wrap up. E is the what the hell did we just figure out? E is the conclusion. Right? Yes?
So, this clarification, alpha is the area that
Yes.
T creates, and then
Alpha is the area that is in the
T value?
either one. Alpha is the area in the tail.
Oh,
Or
so
tails.
it could be C or T?
Totally.
Oh.
Yeah.
Okay. And then P value is just specific. The other side.
The only reason we only do p-values for z-scores, let me see if you guys get this. The t-score chart, is it as detailed as the z-score chart? No. In fact, I want you to realize this. If this wanted to be as detailed, I would need a z-score chart's worth of information for every degree of freedom. So there really is no way to get a specific p-value because this doesn't give me enough information for a t-score. I like it. Technology will spit that shit out at you. So for us, I'm only going to ask you for a p-value for a z-score because then I can use a z-score chart and it's got all the areas I want.
Well, like say with a calculator or something, you could figure it out.
Totally, yeah. It wouldn't be us. It would be it. So that's why I don't care to not show you at this level, because I want you to be able to do it yourself. So yeah, right now we're using this chart. That is not complete information. It only works in certain situations. So it's not enough information to get the p-value for a
It's
t-square.
like the opposite end of the graph, right?
It totally depends. I mean, here's a good question. Can you guys figure out the p-value for this situation if my z-star was negative 1.98? Can you guys figure out what the p-value would be? This is z-star. Alpha is the area in the tail of the rejection region z-score. P-value is the area in the tail of my z-score. I hurted myself. This is a chapter 6 question. Just what's this area? Negative 1.98. Why is that one nice? Because the z-score chart tells me areas that are where? Below the thing I look up. So if I look at negative 1.98, that's the answer. What is it? 0239? Is that what you guys are getting? The rest of you guys are like, I trust you guys. I'll wait for you guys to do it. We don't all have to be doing that, Jeff. 0239? All right. So what about this p-value? If my z-star was, you can do it, Jeff. There you go, buddy. 2.09. What's the p-value then? I haven't heard the answer yet. Yeah. What's the p-value? The area in the tail. This is what I think you were getting at earlier. But it's just that. It's if I look up 2.09, do I get the area in the tail? No, I get this shit. What was it? 9817?
17.
So what's the p-value? Maybe a couple of you guys would look up negative 2.09 because you remember the shortcut. But you don't have to do that. You do what we just did. Yes. Good. That's the next case. If this was a two-tail test, I just do one more step. I double what I just got. And that kind of makes it fair because it was a two-tail test. Alpha went in two tails. So I double that to make it match up with the two tails.
When you add a star, determine what that means.
So right here on this step, if I tell you alpha, it doesn't matter. Let's say that I get 1.96. So if z star is greater than 1.96, we will reject the null. You guys with me? That's the z-score for the rejection region. The reason I give it a z star, that is a z-score, right? It's already a z-score. So I want to differentiate the one I'm about to calculate from the one that's already up here.
Oh, yeah.
So I just call it z star to differentiate it from the z-score it's already up there, the level of significance. Yeah.
So it's like what you use to figure out, like a baseline.
Yeah, I have a z-score that's a benchmark, and then my z-star is where my sample actually fell. So I want to differentiate between the two z-scores we're working with. Okay. All right, so let me do this. So apparently, we didn't do the handout that one side talks about the age somebody was when they first had a baby. Right? You guys didn't get that from me? All right. So let me go back and get that while I am gone. That's great. Do whatever I want. Okay. I was going to give you something to work with. Talk amongst yourselves. I'm going to keep my camera rolling so I can hear everything talk about.
If I didn't fail it, I got
It's a photo. Every time I've been there, it's always right.
So the Z-score is when they say define a rejection region using alpha, and they'll put the independent alpha, and then you use that alpha to find that Z-score. Z-score is as where it's true.
Yeah, so like that's like hard to see.
Where it actually falls is like
You'll find out where, yeah, so you'll find out. I haven't started any homework chapter. It's going to go home. I'm not going to go to bed until we're done. So like, oh shit, trying to run is a lot of Oh, it's finding problems for homework. But you know it's right. Because like this one, this whole page is one problem. Thank God I did like the grade the first beginning of the semester. Good Lord, baby Jesus. Oh yeah, what was it? November 19th is test number 3. It's like next Tuesday, or not next Tuesday, Tuesday. I don't think we'll have a quiz. On chapter 9? Yeah, I don't. Unless we have it next Tuesday. Because that's chapter 8, 9, and 10. Yeah, but I feel like if we're gonna have it next Tuesday, we'll probably have a quiz before, or next Thursday, but then we'll have a test Tuesday, and then because Thursday's not here. Yeah, because next Tuesday, Thursday, because then that test will be the next week. Yeah, no, he probably just has a quiz for the final. Like the kind of like after half of everything. I wish this was the last quiz. Well, I don't, because I got a terrible grade, but at the same time, like I'd rather just have the next test and test after. You want to know something that's crazy? Ever since I stopped doing it, I started doing better. My quiz grades have gone from 75 to like 95. Yeah, no, I couldn't do the homework and the homework. Yeah, every time I do it, and then I'll do it, I'm like, you know, in this class, this doesn't make sense. I do the first section of each one, and I'm like, I'm still getting a great grade on my quiz. Maybe not so great on the test because there's just so much to remember, but still, I'm really good. For sure. But I do understand why he does all the work like that, just because like it's so, if you know, if you understand the more about you, then you'll just understand the class. But for me, like the brain doesn't work like that. I'm just being confused. Yeah. And the book will be like, you should have to do this, and like, that teaches you not done well too. Like, I have to do something else, so I don't even, I do some of it, and I turn it in, but I'm like,
Watching the slide.
You're right.
I need to time the
All right. If anyone tells me, oh yeah, I got this, I'm gonna have to hurt everybody.
Yeah. I really don't even think I got that right. Some like other colleges, like my sister for Oxford, she's graduating actually tomorrow.
Be there.
And her grade was based on one test.
All right.
I would definitely take that. I see not though, because you have like the whole semester to work on it. Oh, right. Yeah.
All right, cool. Okay. Let's do this. Everybody's got one of these, right? Weird. Ah. It's like they made this room and they said, "Oh yeah, we have to teach here." All right. So, read through that. What about the age somebody is going to have the first? Since when?
Since like the 90s.
It's gone up.
My mom was happy. She got 4 daughters through that.
There are much fewer teenage pregnancies. I'm not saying there aren't any, but there are fewer, so that's going to make the average go up.
Oh, no, I'm sorry, what I meant was like there's less teenagers.
Yes, which means the average age of first
Of
birth
is
is going to go up.
Yes, yes. Why would you bring up?
Yeah.
Also, like raising a kid
Well,
is so expensive.
somebody who was in the 20s and the 80s, it's much different than somebody who's in the 20s now. It's very different. So yeah. All right, guys. So, having read through this now, what's the claim that's being made? So what? Yeah. So the words you look for to figure out what the claim are include the word claim, the word belief, the word feel. We feel that it's done this, something like that. So we believe that the average has changed. Changed from what? Yes, you're never going to see the 25.29 number in the first step because that's what I get from the sample. I got to first set up what I think before I go take a sample to investigate what I think. So here, the mean, so we think it's changed. So we think the mean is, no, we think it's changed.
But how do you know?
What do you mean?
How do you know, like, how it changed? Like, 'cause
No.
usually it doesn't say-
We believe it's changed. So what would be evidence that it has changed?
that it's
If the
not-
mean is not equal to. That's it. Which way could it go and show evidence for our claim, up or down? Yeah, that's what that means.
So if it was saying, like, we believe the average has changed or increased.
There you go, that's a
then
directional
something
word.
That would, yeah.
That is a directional word. It's going to be a one-tailed test. If you don't see any directional words, it more than likely is a two-tailed test. Yeah.
So even if they tell you that the average, like in this problem, has gone up, you still can't.
No. They don't tell me that anywhere. What do I do before I conduct an experiment? I set up what I'm going to test. So I know in this problem, I just vomited all the information at us across the whole timeline. But what chronologically? I set up my claim. Then I go take a sample. And then I see what I see in my sample. So I can't base my claim on what I see in the future. Yes?
Okay, so if it's one tail, you would, like, in your little drawing, you would shade it, like, going towards the left.
Depending on if it's
like
greater or
this.
less than.
Okay.
The little arrow tells you which way to shade.
And then you would use that shaded area to find, like, later on if they ask for a p-value.
No. P-value comes from my z-score. Has nothing to do with the alpha and the rejection region. No. Okay. Let's just try this one. So where does that go? Okay. Yes. Because it has a not equal to, so it has the definition of no equal sign. So what's the opposite of that? That's crazy. So is it going to be one tail or two tail? 2, because not equal to, I could show evidence going up or down. Just has to change somewhere. So it's a two-tailed test. What do I got to check to see if I use Z or T?
Do you have a sample or a population standard deviation?
True, but what's the first thing? How about, what do I check to make sure I can do something? Yeah, so N is
Greater than 30.
N, 264, which is bigger than 30. So I much prefer you to prove a statement rather than just state something. Don't say N greater than, show me that it's greater than 30. And then you check. I really put this in your face. Which standard deviation do we know?
Sample.
Population.
Oh, I'm sorry.
Yeah, we know the population. So what am I going to use? Z. So this step says you can do something, and this step says which thing can you do, Z or T? All right, so now I know alpha, also known as the level of significance. Because if I pass this test, that will be very significant, because that is a very small alpha. It's going to be a hard test to pass. And you're all like, you got that right? So I know it's a two-tailed test. I know I'm using Z-scores. And I know alpha is 0.005. Can you look at your T-score chart to tell me what the Z-scores are? I don't hear any paper. It's kind of disturbing me. Ooh, I like it. Because he's looking at the Z-score chart.
Oh, okay.
If you look at the T-score chart, it's better.
It's, yeah, 2.57.
Area in, oh, is this the one I gotta change? Yeah. All right. I made this into two tails later. Now, to be honest, all right, I didn't mean to make this so evil. I think originally it was a one-tail test, and I put 0.005. Right. So let me change this to 0.01. So now it's a two-tail test. I would change that. That's what I would give you. How did you know to change this? You never would change it. I would have just given you this one instead. So if I look at two tails, 0.01, two tails, 0.01, and do I want to stop somewhere? I want to go all the way down bottom because it's a Z-score. If you stop, you get a T-score. If you don't stop, you get a Z-score. What's happening? We all know this. We all know that T-scores cover my ass, and they have to do more of a job if the sample gets small.